Hello everybody and welcome to another React Native Show episode. Today we are going to talk about Re.Pack, a very interesting open source library that uses Webpack. So we're going to learn what this has to do with React Native and why you should be probably using it. Today with me is a very special guest, Paweł, that works with me at Callstack. So Paweł, very nice to not meet you because we know each other, but I'm pleased to have you on this podcast. How about you just introduce yourself in a couple of words for those of our listeners that are here, for the first time, before we go into the Re.Pack and all the benefits that it has.
Hi, Mike. Thanks for having me. I'm Paweł, also known as Zamotany on the internet. Like Mike said, I work here at Callstack. I'm a software developer for more than 4 years now. Really excited to be here.
Nice. Great. I'm also really excited to have you today because we have a very special topic that, is something that you've been working on for a while now. So, I know the name is Re.Pack. What can you tell me about this project?
Okay, so Re.Pack is a direct successor to Hull. Hull was also an open source project that we did here at Callstack. And essentially a Re.Pack is a toolkit for React Native applications that works with Webpack. So Webpack is a bundler for your JavaScript or TypeScript code, and you use Re.Pack to make that bundle that Webpack generates work with React Native. So while Webpack is a bundler, Re.Pack is a toolkit or set of APIs that allows you to use Webpack for developing React Native applications. It has support for features like Hermes, Flipper, or React Refresh. We plan to add more features that are exclusively available in Webpack, which you cannot, for example, do in Metro.
Wow, that's quite a lot of keywords in a single answer. And I guess before we go into the details, it would be great to talk about some basics. Like, for example, what do we need a bundler for in context of React Native if we are actually building a mobile application?
Yeah, so when we are writing the code for the React Native, we usually write it in JavaScript or TypeScript. And this code is split between multiple files, right? Your source code consists of multiple files, and you also have dependencies that lives in, for example, node modules. So those files might contain a syntax that is not well understood by the JavaScript VM. For example, you're using arrow functions or const on let. This is the syntax that might not be supported yet in JavaScript VM. So you have all of these files that are not runnable right now, and you need a way to pack them together into a single or few smaller files and transform them at the same time to something that the JavaScript VM understands. And this is what the Webpack does. It takes your code, it transpiles it, for example, with Babel, and packs it together alongside minification happens to make sure that you ship the smallest possible code without any comments or additional stuff that affects the size. Because the less code you write, the less time is spent on evaluating and processing that code.
Yeah, and I guess, for that reason, Facebook had to develop Metro. I mean, I guess we'll get into that a bit later, but there is already Metro in React Native, which is kind of the default. And every time you actually install a React Native locally on your machine, this is what you get. So I guess, what would be the biggest selling point of Re.Pack if I were to use it over Metro?
So the biggest selling point of Re.Pack is that it's based on Webpack. Re.Pack itself is not a bundler, so it's not a direct competitor to Metro, but it's a set of APIs that will make Webpack a bundler for React Native applications. So the the biggest selling point, like I said, is Webpack, because it supports a lot of features that are not otherwise available for React Native developers. Like, you have this whole ecosystem of Webpack loaders, plugins, and the vast amount of configuration options. So the strength of Re.Pack is that it's based on the Webpack, essentially. And the Webpack has been in the market for years now and has a widespread adoption, especially in the web development community.
Yeah, that makes a lot of sense. And before doing this podcast, I also did a bit of research, and it turns out that there was actually an attempt to use Webpack with React Native early days, just before the Facebook team decided to build a packager, later rephrased to Metro and a separate project. And I guess there is also an issue number 5, that we have linked to this article, so we can go and check it out. But I guess the primary reason the Webpack was not used was performance and lack of support for some Facebook-specific things, like, I guess, haste modules that some of you may not remember, but they were quite popular back in the day. Back to the Hull, which is like predecessor to Re.Pack. I'm just curious, is that also why this project, despite being, I guess, quite popular and conceptually offering the same thing as Re.Pack, never really got to the point where you were kind of satisfied with it and had stable feature set, and eventually now it is sort of discounted in favor of Re.Pack. So I'm just trying to understand what specifically led to that decision, that Hull never really got into a stable phase.
Yeah, so the main problem with Hull was its architecture. We designed Hull to encapsulate Webpack under the hood. So Hull had its own configuration file, and we had to maintain that configuration file. We had to maintain all of the documentation for it, while we still were using Webpack under the hood, and had to convert from our configuration file format to Webpack's one, so that Webpack can actually run. And because we hid Webpack behind this facade, the issues that people had with Webpack were also our issues, because they were opening new issues on GitHub to our project instead of Webpack, while a lot of the problems that developers had were already solved and you could find them on Webpack's GitHub. So that was the one thing. And another was that because of this maintenance overhead, the feature development velocity was low. So it was difficult to develop new features, and sometimes even impossible or not feasible, like in case of React Refresh. The whole architecture didn't really work in a way that would allow us to do that, especially since we had to also support RAM bundles, which complicated the whole code to a point that it was just not possible to implement latest and greatest features that Metro had.
Yeah, that makes a lot of sense, and I can definitely relate that. Over time, I've also learned that sometimes building these nice abstractions while making it easier for developers to use, sometimes it's just not paying off in the long term. So, I'm curious, what was the game changer for you that made building Re.Pack possible? I guess you're now you're now satisfied with the way Re.Pack looks like, and still it is based on Webpack. So what is different now about Re.Pack or Webpack, or your approach, that makes Re.Pack such a good alternative and actually something that you believe is going to be working really nicely?
Yeah, so there were 3 things that allowed us to create Re.Pack and support all of the feature set that Metro has. So the first one is the release of Webpack 5. That was a game changer for us. A lot of the internal code was refactored in Webpack 5, which makes it easier to understand and read the source code, which was the reason why we could create, for example, hot module replacement with React refresh support into Re.Pack. The other thing was that instead of hiding Webpack configuration, we now embrace it. So the developers have access and they own Webpack configuration, and they just use our APIs like plugins to tweak the configurations to their needs. So whenever the developer have an issue with Webpack configurations, let's say some loader doesn't work as they expect or something is not transpiled properly, they can search directly for that issue inside Webpack's GitHub repository or somewhere on the internet, on Stack Overflow or something. The last part is that we've decided not to support RAM bundles. It was our deliberate decision based on the experience we've got with Hull, since the support for RAM bundles complicates the code exponentially. So if we were to support RAM bundles, we probably wouldn't be able to support React Refresh. So we opted for the greater developer experience instead of having to support RAM bundles, since they are not that widely used.
Yeah, and that makes a lot of sense. I guess sometimes you just gotta make these decisions about not supporting everything, especially when the future of certain features is not really settled yet, and it may happen that RAM bundles are not popular in the future, especially when Hermes, kind of becomes more popular. So like what I'm sensing here is that Re.Pack is then a super fresh development and opens up like all great Webpack 5 features and its powerful ecosystem. So what does it mean in practice? What kind of features are we talking about?
Yeah, so in practice, we support all of the features that Metro does. So you could use Hermes, you can use flippers with all of the React Native specific plugins like React DevTools, Hermes Inspector, and other. Additionally, we have fully featured development server. So it works out of the box. You just run different command and that's it. So it's not a drop-in replacement, but it's close to. And one of the major benefits of Re.Pack is that now we can support code splitting in React Native. So you can split your bundle into multiple files. And in the future, we will be able to use module federation for developing React Native applications.
Nice. And I'm gonna ask you about these features in a bit, because this is really interesting to talk about module federation and code splitting. Generally, I'm really excited. Like if I were to say what's the biggest selling point for me, that would be definitely symlinks, because that just makes my development easier. But I guess jokes aside, that's not the primary reason why somebody should be choosing Re.Pack over Metro. Actually, in the README of the project that I have checked, beforehand, you explicitly say that it is targeted at advanced developers. And that said, I'm curious, what are these scenarios that make using your library a no-brainer? And I guess we are talking about something a bit more advanced than just what I said, right?
Yeah. So let's start with the basics. So one of the use cases that Webpack really shines in are projects that have complex or unconventional project structure. So one of the example is having Git submodules or symlinks, like you mentioned. Those are the cases when it might be not possible to bundle your application properly with Metro, but with Webpack, it is possible to configure it to properly resolve all of the source files, all of the dependencies, regardless where they are. So that's one group of the projects that would benefit from Re.Pack. Another one are the applications that itself could benefit from code splitting. So we have a lot of applications that could benefit from it. Few examples are modular applications. When you have a logic that you don't want to ship to all of the users, but you want to load them on demand, for example, for only specific group of users based on some factors that you detect in the runtime. Let's say user subscriptions plan, right? Another example of applications are so-called super-apps. When you have one big application that consists of multiple smaller apps, and you don't, let's say you have a super app that includes 50 mini apps. You don't want to ship all of the mini apps to the end user. You want to ship the least amount possible and download the rest on demand if the user wants to use that app. And in general, all of the applications that wants to download the code or extend functionality in runtime on demand. Another option is some kind of text processor. When based on the language you write, you detect what language the user is using, and then you want to download some code for analytics or on some AI based for that specific language.
Yeah, that sounds really interesting. And you mentioned quite a few very interesting use cases, like those mini apps or super apps, and and like the way you could potentially build your application, have those dynamic pieces downloaded. That's really interesting. And I guess these are the projects that become more and more popular with React Native as it matures. But you also said that these are the projects that would greatly benefit from using Re.Pack. So what kind of benefits are we talking about here? Is that TTI or something else?
Well, kind of. TTI is one of them because the less code you ship and parse and evaluate at the startup time, then the less time is spent. So you can quicker get to interactive point of your app. Time to render is also a metric that would benefit from code splitting, especially if you combine code splitting with Hermes, where you can remove the parsing part of running your code at startup altogether, because that part is done at build time. So then the only thing is to just evaluate the least amount of code possible and load the rest later once it's needed. So that's one of the reason where TTI or TTR can be improved. Another one is just basically being able to load content on demand. It is possible with Metro, but there are few challenges and it's limited to do that. So it's not something that is well researched or well investigated. While code splitting has been around for years in web development community, and Webpack has a great support for it. So why shouldn't we benefit when writing React applications for that? Another benefit that you would get in the future with module federation is better scalability of your teams. This is mostly for the bigger companies or enterprise companies that have a lot of teams. So with module federation, you would be able to give control of the build pipeline to each of the teams separately. So each of the teams can develop their part of the application in isolation, individual from the rest of the team. and then they control the build process, so they can tweak it to their needs. They can add dependencies that they want, and then they build the so-called container, but we can say it's a bundle. They build their own bundle, and in the final step, all of the bundles from all of the teams are being put together into React Native application, and that application will run everything accordingly to your functionality. So it's easier to work in isolation, and it's easier to scale your teams with module federation.
Yeah, and that last example that you said is very interesting, because you said that you can have each of your teams to work separately, build it the way they want, and at the end of the day, you can combine it into a single app. And that pretty much sounds like having your own app store, having your own SDK and platform. And if we change your different teams with different companies all around the world, it seems that with Re.Pack and Module Federation, I can build something like a platform. Say React Native for TV OS, that's gonna be a OS. And with Module Federation, I can build like an App Store SDK, and others can target my environment. Is that right? Sort of conceptual from the conceptual point of view?
Yes, I think so. With Module Federation, the limitations are pretty much endless. So you can do whatever you want. Module Federation doesn't only necessarily means that you will have one app and teams that build bundles. You can have teams that require use of some code from other teams. It's also perfectly fine use case. The Module Federation was created for so-called micro frontends in web development. You can read it online if you want. So the use cases are huge, and with Module Federation's support in React Native, thanks to Webpack 5 and Re.Pack, you would be able to create your own app store or some kind of host app that would run other applications that are developed not necessarily by your team, but they can be developed by external team. You will supply to them development host app. It doesn't have to be a production one. It can be any basically host app, which is just a regular React Native application with your mocked API or stubbed API. And then they can develop for that. And at the end of the day, they ship the compiled bundle to you, and you pack that into a single application and ship it to the end user. And actually, you don't even have to bundle that into the final application. You can also host it on the server, and your React Native application, the production host app, will download the bundle that the external team created from the server. So the possibilities are endless.
Yeah, that sounds really, like, I know that I'm saying that, all your answer sounds really exciting, but this is actually a very interesting piece of technology. And, it is really interesting to see that by doing something that looks, at a first sight, very standard, like, oh, here we're just going to make Webpack support for React Native, you can enable so many great features. Like, this is really, a surprise, but at the same time, it shows that, you can essentially use tools that are already in the market to create something very, very challenging and extraordinary. So at the very end, you mentioned that you don't necessarily need to bundle it with your app. You can put it on the server. So my first thought is, CodePush, which is kind of kind of the same, let's say. I mean, you can dynamically extend your functionality, like write something like new module and push CodePush update. So I know that Re.Pack is different, but just to make it clear for everybody, like what's the difference between CodePush and the dynamic delivery done with Re.Pack?
Yeah, so function, essentially the difference lies in both mechanism, how it works, and the use case. With CodePush, once you have your update, this update will be downloaded by the React Native application, and it will override your existing bundle. And this is usually a single bundle. And then on the next restart of the app, the new updated bundle will be loaded. So you will get the new code that you deployed to CodePush. But with Re.Pack and the code splitting module federation, you can load the functionality into your already running application at the same time. You don't have to restart the application to use the functionality that got downloaded and evaluated. So this is a different mechanism, how it works, and different use case. The CodePush, it's great for shipping fixes or changing some small stuff inside your bundle, but code splitting and module federations allow you to write different kind of architectures for your applications, where you only load code to either specific group of users. For example, you have e-learning applications and you have most of the users are students and you don't want to load functionalities for the teachers. So you don't ship that functionality by default. And if teacher logs in, you detect that he's a teacher or they are teacher, and then you download the bundle for the teacher.
Yeah, yeah. Very good example. Thanks for making this clear. I actually also have like an example, I guess, that works here, which is very close, for example, to my area of interest, which would be, the automotive app to control your car. Probably as soon as you select your make and model, or maybe put your ID number, you get download, like the app could download the specific functionality for your particular make. So that makes sense. Cool. So, we have talked about a lot of different features, and it's great to hear that while we initially started talking about the performance, we ended up also talking about some interesting use cases, which means that Re.Pack is not only about performance, but it's also about bringing some really interesting use cases into practice. But I'm going to stick to the performance for a second, because a few questions before we have talked about TTI that, that apps can benefit from, can improve TTI when using Re.Pack. And I guess, I just wanted to ask if you have done any benchmarking around that use case. What kind of improvements are we possibly talking about?
Unfortunately, no. We haven't done any benchmarks yet. We plan to do them later. Right now, with Re.Pack, we are in kind of early stages, which means we have all of the features that we need for the feature parity with Metro. We have basic support for code splitting in forms of asynchronous chunks. But we first want to focus on delivering improved support for code splitting and implement module federations support first, and then we can do the benchmarking, because now we will have a final base for the benchmarking. Without module federation support and improved code splitting support, it's hard to benchmark it, because the benchmarks can be invalid or will be invalid later once we change the code.
Yeah, that is a good approach, and I'm going to ask you about the future plans in a second. There is one more question that I just figured that I would ask you regarding performance, which is related to what you said before, that with Re.Pack you can actually load the code into the already running application. Now, I have actually done a bit of research, and I know that there are people out there that were or are trying to achieve a similar functionality to Re.Pack by instantiating multiple bridges, like 1, 2, 3, 4 bridges. And like the bridge API, for example, on iOS, you can init bridge with URL, for example. So they would init a bridge for every chunk, let's say every React Native app, and they would create an abstraction to asynchronously communicate with the bridges. I guess with Re.Pack, you go for much better approach because there is just one, I guess. So that also means some memory benefits, I guess. If you could just help me understand and maybe explain to others the differences here, because I guess some people that are interested in this topic might have seen that multi-bridge solution, let's say.
Yeah, so I think the feasibility of solutions with having just a single bridge and multiple bridge should be evaluated by case. It's hard to generalize for that. But with Re.Pack, you can have both, or you can migrate to both. Let's talk about the situation with the single React instance. And single React instance also has a single JavaScript context. So you could have single one and just share it across and load the chunks, the code that you split it into it on demand. This is most of the cases you would use that. But if for some reason, and this has to be specific to your case and your project, you decide that you want to have multiple React instances and you're fine with the drawbacks that go with it, then Re.Pack can also help you with that, because now you could just have a index bundle, host bundle. We can name it however we want. The first bundle that gets loaded that contains your dependencies, and then each of the React instance will load only their specific chunk that they need to access. So instead of loading the whole bundle with all of the chunks and just using part of the functionality in each of the React instance, you have each of the React instance load the dependencies, the minimal amount of runtime, and then only the functionality that is specific to that React instance. So you save on the memory and on the time, especially on the start in that scenario.
Yeah, that makes a lot of sense, and it actually shows me that with Re.Pack, I just have more control. I can choose one bridge, multiple ones, and what is most important to me is the ability to actually avoid like instantiating React Native within every bridge. I guess what is happening these days is that if somebody does 3 or 4 bridges, they just duplicate the runtime in these multiple places. So that's definitely something that they should not be doing. Okay, cool. So I have one last question. I guess we have covered pretty much everything, I guess, regarding code splitting, but I'm pretty sure there is still like hours of discussions on use cases. So if anybody is interested, just give us some ideas. We can probably with Paweł discuss some of these projects in our podcast. But before we drop off, I just wanted to ask you, like, how can I get started? This all sounds very interesting, and sounds like something that I'd love to start using now. Is this all already available? How can I get started? What's the plan here?
Yeah, so good news, it's already available. We have a repo for that on GitHub. It's already published to an npm. The code is open source, of course. And we are at the stage where we have a feature parity with Metro, except for RAM bundles, which we deliberately choose not to support. So you can replace Metro if you want right now. And we have a basic support for code splitting, meaning that you can use so-called asynchronous chunks by writing a dynamic import function inside your code that will create a chunk. This has some limitations, and you can read more about it in our README. But we are working right now on improving this support so that those chunks, you will have a better control over where those chunks are stored. So you will be able to store them in-app, so that that chunk will be packed inside your APA or APK file, or you will be able to store them on the server and load from the remote location. So we're working on bringing that functionality alongside other APIs for the chunk management, like invalidation of the cache and what's so not. Then we are focusing on bringing the module federation into React Native, because we think that's a game changer for writing complex React Native applications. So that's our plan. You can already use it, but you will have to wait a bit for all of the good stuff that we just talked in this podcast.
Which I guess is a nice thing to be waiting for. You, Paweł, definitely tease us all about what's coming up, because I'm pretty sure that these use cases are something that a lot of developers, at least once in their lifetime, have stumbled upon. So, Paweł, thank you very much. It's been a pleasure to have this podcast today with you during this beautiful sunny day. I hope that you enjoyed it, and then that's not gonna be the last time we are having this podcast. What you think?
Yeah, definitely. We can do more podcasts in the futures. If there are any questions or any topics that we should cover, let's just do it. And yeah, thank you for having me today.
Nice. Thanks, Paweł. Now I have it on tape, so I'll definitely be getting back to you. Anyway, yeah, that brings us to the end of this podcast. Thank you everybody for watching us, listening us, regardless of the platform that you are consuming this podcast. Just a casual reminder that you can follow us on Twitter. You can check our YouTube account, where the video that you are maybe listening to is available. If you prefer audio podcasts, we also probably are on every platform. To find the available platforms, just go to callstack.com/React Native Show, and you will have all the links and our previous episodes there to enjoy. So with that said, thanks you, Paweł, once again. Thanks everybody, and see you on the next episode of React Native Show.